Hello viewers, in this tutorial we are going to learn about Oracle Real Application Testing or RAT, which is a very useful feature in Oracle to compare performance of the database during any major change in the database environment, such as upgrading the version, migrating the platform, or upgrading the hardware, etc. And I will walk you through all the steps required with practical examples to perform a RAT step by step. So what is RAT? Oracle Real Application Testing or RAT is a feature that enables you to perform real-world testing of Oracle database performance. RAT is based on workload capture, workload replay, and SQL performance analysis, by which we compare the performance of a database before and after a change. This change can be a database upgrade, say you are upgrading your database from 18C to 19C or even a newer version like 21C, or you are migrating your platform, say from Windows to Linux, or you are upgrading your hardware from, say, a traditional server to an Exadata server. For this kind of major changes, RAT will let us know how the database performance will be in the new environment. RAT helps us evaluate a candidate database's performance even before we actually go live with our changes. So how RAT works is, first you need to find out a time period in your source database when there is a representative workload from user or application activities. You capture that workload as some SQL tuning sets or STS in the source system, transfer the workload to the target system by, say, export import, and then replay the workload in the target system using some inbuilt methods, procedures, functions provided by Oracle. Once your replay is completed, you extract a few AWR comparison reports from the target system, which gives you a full analysis of how the performance of the database during the representative workload replay. With the analysis and comparison reports, you can find out many performance related metrics like load in the system, wait events, resource consumption, execution time and plan of SQL statements in the target system, and get a fairly nice idea about how your database will behave after the actual cutover or go live. And if you see any performance issues, you can fix them by tuning further, like changing the memory footprint, adjusting any initialization parameters, or creating SQL profiles, etc., and do the workload replay again to see if the situation has improved. I have used this feature more than 100 times when I and my team migrated 500 plus databases in AIX to Oracle Exadata in a massive project that we handled a couple of years back. Even now we use this feature when we do a major database version upgrade. With RAT, we can produce reports that provides evidences with a before and after comparison of an upgraded or migrated database and identify the real cause of an issue, if any. For a RAT testing, you need a source database and a target database. Target database does not have to be an exact current copy of the source. It can be an ARM and restore database or an export-import copy of the source database. But in terms of application schemas, or the schemas in which you are evaluating the database performance, the two databases should be structurally similar. Otherwise, the workload replay will fail in the target or throw some errors due to missing schema objects like tables, views, types, or other database objects, because workload replay in the target is nothing but executing a set of SQL statements and PLSQL blocks that was captured from the source database. For this demonstration, I will use an Oracle 18C database named CatDB as my source database and an Oracle 19C database named RAT-Test1 as my target database in an Oracle Enterprise Linux 7.9 environment. I will create a mock workload in the source database by running a PLSQL block with a few SQL statements in an infinite loop for 15 minutes and capture it by running RAT commands. Then I will transfer the workload and replay it in the target system. Please note that in a real database system, you don't have to create a mock workload because there is always something going on from the application or user activities. You just need to select the right time period, say an 1 hour or 2 hours period during the peak hours to get a representative load. So before we start the RAT commands, let's establish our test case one more time. Say we are planning to upgrade our 18C source database to version 19C in the same Oracle Enterprise Linux 7.9 platform, and we want to see how the database performance will be in the Oracle version 19C with a representative workload. So I logged into my Oracle Linux 7.9 server as Oracle user, and this is my server, Red Hat Enterprise Linux 7.9, and I have two databases here. The CatDB, which is our source database in Oracle version 18C, and the red test 1, that is our target database, which is in version 19. I established a toad session to the 18C source database for executing certain queries to prepare the environment. Any SQL statement or PL/SQL block that I am using in this tutorial can be found in the shared document in my Google Drive. You can find the link to that document in the description of this video below. So first, I am going to create an application user named app user. In a real environment, you don't have to create this application user because there will be application related schemas and users which will be doing their relevant activities. But this is a test database, there is not much going on there. That's why I need to create this user with a password fuser12345, and I'm granting some resource, connect and DBA privilege to the user, and I'm also creating 3 sample tables and some indexes on those tables. And these tables are created from the DBA objects, DBA tables and DBA indexes dictionary views. So I'll just execute these commands as a PL/SQL block so that the tables and indexes are created under the app user schema. There will be a few hundred or thousand records in these tables, and that is enough for our demonstration purpose. And I'm creating one PL/SQL block which is consisting of 3 SQL statements which will be executed in 5 seconds interval. And these SQL statements will be executed in an infinite loop, and this entire PL/SQL block will be executed in a SQL plus session. So I'll establish 3 SQL plus sessions using the app user that I just created, and I'll connect to our source database and execute this PL/SQL block. As it is an infinite loop, it will continue to run until and unless we terminate the session. So let's start a SQL plus session, and I'll connect to our source database, that is the CatDB, using app user CatDB, and the password is fuser12345. And I'll establish another session. The second session, and also a third session. And in these 3 sessions, we will execute our PL/SQL block. The first session, the second session, and the third session. Now that our 3 sessions are established, we'll be able to see them under $sessions view. And yes, we can see that there are 3 sessions currently running, and they are executing those SQL statements to create a mock load in our database. Again, if you are in a real database environment, you don't have to set this up, because there will be always something going on from the application, and all you need to do is to capture that activity. Now we will execute the actual red commands to capture the workload. But before we capture the workload, we have to do certain preparation activities that I am going to do step by step. First, I will connect to the source database as sys. and this is our 18C source database. We'll also open one command prompt in another tab so that any OS related commands can be executed in that tab. So I'll sudo to Oracle user, and here I will create one directory to keep all the captured files. And on this physical directory, we will create a directory object in our database. Let's create the directory object as catdb capture, which is pointing to the physical directory that we just created. Now we will grant read-write permission on this directory object to public. Now the next thing, we need to set up some filters, and this filters is actually filtering in the schemas on which we are going to capture the workload. In our case, it will be the application user schema that we just created with a name app user. So we are going to create the filter using this command dbms workload capture dot add filter user filter, and the user is app user. So the filter is successfully created. Now you can check out the filters that we just created. I will simply check the name of the filter that we created. The name of the filter is user filter. There is no ID associated yet, and the value of the filter is app user, that is our application user schema. Now we'll start the capture, and the capture is nothing but whatever SQL statements are getting executed by the 3 sessions that we just established using SQL Plus, and this capture process will capture those activities. And the command to execute the capture is dbms workload capture start capture, and this is the name of the capture that we are putting here, and it can be anything. I am putting here the name of the database, the capture word, and the date on which I am doing the capture. And we need to specify the directory object where the captured files will be created, and this is the catdb capture, and 900 is the number of seconds for which this capture process will execute. And this exclude word here is actually specifying that whatever filter we have established before, except that filter, it will exclude any other user activities or application activities. Once we execute it, it says the PL SQL procedure is successfully completed. It means the capture process has been submitted, and it is now internally running for the next 15 minutes. Please note that in a real environment, running a capture process for like an hour or so, or maximum 2 hours is sufficient. You don't have to run it for like 8-10 hours long capture process during the peak period. Now whether that capture process is currently running or not, you can find it using this SQL statement. What I'm doing here is select ID, name, directory, directory path, status, filters used from DBA workload capture, and this is simply giving us that a capture named catdb capture 032522, that is the today's date, and it is keeping the captured files in the directory named catdb capture, which is pointing to this physical path, and the status is in progress, and this is using one filter that we created before. Please note that if you want to stop this capture before it automatically finishes upon completion of the defined period, you can also use another command called dbms workload capture dot finish capture. If you execute this command, then whatever capture is currently in progress, it will be stopped, and instead we will wait for 15 minutes to complete the capture. And you can repeat this SQL statement and it is still in progress. Let's execute the query to see the status one more time. It is still in progress. Okay, we just completed 15 minutes looks like. Let's see the status again, and yes, now the status is shown as completed. The next step is to create a SQL tuning set. So I'm using the DBMS SQL tune create SQL set, and the name of the SQL set is SQL set catdb and today's date. Description: catdb SQL set for replay. And we'll execute this procedure, and the SQL set has been successfully created. Now that capture process has completed, and we'll be executing the next level of commands in our Toad window so that it becomes easier to understand. And the first SQL statement that I'm executing is giving us that the capture process has completed. Next statement we are going to execute, which will give us the AWR begin and AWR end snapshot, which is relevant to the capture process that we ran for 15 minutes. So for that 15 minutes time period, this is the beginning AWR snapshot and this is the end AWR snapshot. These AWR snapshots are important because we have to take all the SQL statements which are in between these two snapshots that will include in the SQL tuning set that we just created. So what we are going to do in this PL/SQL block, in the declare section, we are defining one cursor, and in the begin and end block, we are running a cursor for loop and collecting all the SQL statements in between these two snapshots 4670 and 4671 and including them in the SQL tuning set that we created. So let's execute this PL/SQL block, and the PL/SQL procedure successfully completed. Next, we have to create an user in the source database which will be used to pack the SQL statements in the tuning set, put it into a table, export that table, and import that dump file of the table in the target database. I am simply keeping the name of the user as STS1. Say create user STS1 identified by welcome1. It's just a temporary user we are creating for the purpose. So the user is created. Then I am granting it some privileges. So connect, create session, create table to STS1 user. And I am granting unlimited table space to the user. Now I'm going to create a staging table in this STS user schema. So PL/SQL procedure successfully completed. So we just created the staging table. Next, we are going to pack the tuning set that we created. So here we are using the DBMS SQL tune .pack staging table underscore SQL set, and name of the SQL set is the one that we created before. The SQL set owner is sys. Staging table name is STS capture catdb that we just created, and the staging schema owner is STS1. Let's execute this PL/SQL block, and the PL/SQL block has been successfully completed. Next, we are going to export this table using expdp in the command prompt. I am just pasting the command here so that it becomes easier to understand, and I'm going to use the sysdba user, and the dump file name will be sts capture catdb.dmp. Log file will be similar .log. The directory will be the one that we created before, and the tables is nothing but the sts1 user dot sts capture catdb. This is the table. So let's copy it from here, and I will go to the command prompt and I'll simply run it. And our export activity has been successfully completed. Now we need to export the AWRs, and to do that, first we have to find out the capture ID. So we'll go back to our Toad window and execute the command, which gives us the ID, that is the capture ID, name, directory, status, etc. And most importantly, we need this ID field, which is 1 here. And next, we need the AWR reports for that particular capture ID. So we are executing the DBMS workload capture dot export AWR for the capture ID 1. So we'll simply execute it. And this statement is going to take some time because it is actually exporting all the AWR related information for this capture ID for the period that we use to capture the workload. And all this information are actually written in some files in the directory that we created in our file system. So if you go back to the folder that we created, you will be able to see that there are some files created here, and these are the capture files and the SQL tuning set table that we just exported, the log file, and some directories related to the capture files. So we have to wait until this process finishes. It usually takes like around 5 minutes. It is based on how big is your workload capture. Now, in fact, our capture process finished long back. We don't have to continue running those PL SQL blocks in the SQL sessions that we established. So we'll simply go and terminate these sessions. The second one and the third one. Okay, after running for around 8 minutes, the export of the AWR procedure has been successfully completed. Now we are in the last step of completing our capture process, and for that we have to go to the OS level and see the size of the directory that was used to keep our tuning set dump file, all the AWR snapshots, and any capture related files. And it's 49 MB, and we need to zip this file and transfer to the target system where we want to replay our workload. Now, whatever workload we just captured in our source system, everything is packed inside this folder. So this folder needs to be transferred to the target system to replay the workload. So we'll first compress this as a zip file and name it as catdbcapture.zip. So we created the zip file. So with this, we completed the workload capture in the source database, and in the next we are going to transfer the workload that we captured and created the zip file to the target system. We will uncompress it and then we'll replay this capture in the target system. I have established 2 Toad sessions to the source and the target database to execute various SQL statements and show the results time to time, but mostly I will be using command prompt. Before we can replay the captured workload on target database, we need to make sure the application schema in the source database on which we are analyzing the performance of the database is also present in the target database. In our case, this application user is app user. And in the source database, that is the catdb, this application user has a few tables and indexes. And in the target database, that is rattest1, we don't have these objects and not even this user. So we have to bring this application user schema or the app user schema from the source database to the target database along with all its objects. Normally, we do that using datapump export import if the schemas are small, say less than a few hundred GBs, or an arm and restore of the whole source database to the target database if it is large. You can also set up a golden gate replication from the source to the target database. The purpose is to make sure that the application schema in the source and the target database are structurally the same. In this tutorial, as our source schema named app user is very small. So we will be using a data pump export import from the source to the target database to bring this schema with all its objects. To do that, let's first create a data pump directory. We'll create this directory, which will be pointing to the /temp physical folder in the host, and this temp exp directory object has been created, which will be used by our data pump job. And I am simply pasting here the expdp command that I'm going to use. The expdp user ID will be sys, directory will be temp exp, the directory that we just created in the previous step, the dump file and the log file, and the schemas. This is the most important parameter here because we are exporting the app user whole schema through this export job, and we are using the flashback time and the sys timestamp as parameter here to make the dump file consistent. And I'll simply copy this now and paste it in our command prompt. So this export job is actually exporting the app user schema with all its objects from the source database named catdb. Okay, so our export is just completed. Now we'll be importing this dump to our target database, that is the rat test 1. So we'll first connect to the target database, and then we'll create the same directory object here as temp exp that we created in the source database. You can give it a different name, but just for simplicity I'm using the same command here to create the directory object. And now I am going to do an import of the dump file that we just exported. So let me explain the import command here. It's using the impdp command. User ID will be sys, directory the temp exp, dump file will be the file that we exported from the source, the log file name, and the schemas will be app user. The user or the schema that we exported from the source will be imported here using this impdp command. Now let's take it to the command prompt. And I'm simply pasting it here and executing. Now our import has successfully completed without any errors. So now we can go and validate the structure of or the objects in the app user schema in the target database, and we can see that the same index and the tables are present in the app user schema in the target database. Now let's go back to the Linux prompt where we created a directory named ratcap under Oracle users home directory, and we have put all the captcha related files, AWR snapshots, dump of the staging table having the SQL tuning set in this directory called ratcap, and we created a zip archive of this directory named catdbcapture.zip. Ideally, we transfer this zip archive to the target system and unzip it to start our replay activities. But because our source and target databases are in the same host, so instead of transferring this zip file, we will simply unzip this zip file to a different directory so we do not overwrite the source files in the directory called ratcap. Unzip -d rat rip catdbcapture.zip. So it is going to unzip this zip file to a directory called rat rip. So this rat rip directory is created. Let's go inside this. And there is another subdirectory with the same name created, and we don't need this subdirectory actually. So we will move all the files under this to the parent directory. So mv star and then we will get rid of this blank subdirectory. Next, we will connect to our target database using SQL prompt as sysdba. And we will create a directory object that will point to this rat rip location. So I'm using this command, create or replace directory catdb replay as home oracle rat rip, and the directory object has been created. Now we'll grant read write privilege on this directory object to public. Next, we need to make sure that the target database is in archive log mode. So let's check the archive log mode is enabled, and yes, it is in archive log mode. And we also need to make sure that we have enabled flashback in this database, and then we have to create a guaranteed restore point. First, let's check if the flashback is enabled, and we see that the flashback is enabled. Next, we are going to create a guaranteed restore point in the target database. So create restore point grp before rat replay guarantee flashback database. So the guaranteed restore point created. Next, we need to import the SQL tuning set that we created in the source database. If you remember, we created an user named sts1 in the source database that has the staging table that contains this SQL tuning set. So before we can import the SQL tuning set or the staging table that contains the tuning sets, we need to create the sts1 user first in the target database. So I'll create this sts1 user in the target database with the same password and some grants. And this is just a temporary user, and you don't need this user later on after your replay is done. And we'll also grant connect create table, and additionally I am giving DBA privilege just to avoid any kind of privilege issues going forward. And as I said, this is a temporary user, and you don't have to keep this in the database once your replay activity is done. Next, we are going to import the staging table dump that contains the SQL tuning sets. So I'm using this impdp command. impdp user ID is sys, dump file is the staging table dump file for the SQL tuning sets, the log file, and the directory that is the catdb replay we created just a few minutes back. So copy this and execute it in the command prompt. And the staging table dump has been successfully imported to our target database. Now let's connect to the target database using SQL prompt and see how many records are there in the staging table. And there are 3032 records in this staging table owned by sts1 user, which we just imported. Now the next thing is we have to unpack these SQL tuning sets from the staging table, and to do that we will use a PL/SQL block that I am going to explain in the Toad window. So this is the PL/SQL block we are going to use to unpack the SQL tuning set, and using the dbms SQL tune dot unpack stg tab underscore SQL set, and we are simply specifying the SQL set name, the SQL set owner, that is the sys, and some other parameters here, right? Like replace equal to true. If there is any existing SQL tuning sets, it will be replaced. And staging table name will be sts1 capture cat db, and the staging table schema owner is sts1. We will copy it and paste it in the command prompt. Set timing on, so that we know how much time it is taking. and it took just like less than a second. Next, we need to get some captcha related information. That is nothing but the captcha ID. And the PL SQL block that we are going to use is this one, the DBMS workload captcha.get captcha info, and we have to specify the directory name, and from there it will collect all the information along with the captcha ID, and that is important for us. So I'll take this block and we'll paste it here, and it has given us all the information we need. That is the captcha ID, which is 1 here. And this captcha ID will be used in our subsequent commands. Next, we have to import all the AWRs that has been exported from our source database. To do that, we are going to use a PL SQL block that I'm explaining here. And we are using the DBMS workload captcha.import AWR procedure here, and we are specifying the captcha ID there, and the staging schema name, and force cleanup equal to true, and we will simply copy it from here and paste it in our command prompt. And this procedure is going to take some time because it is importing all the AWR related information to the target database. Okay, so the PL SQL procedure successfully completed, and it has returned a DB ID equal to this. Now this DB ID is different than the DB ID that belongs to the target database. So this is coming from the source database, and we can validate this simply executing this command. And if you see that these two DB IDs are different, one belongs to the current database, that is the target database, and the another one is from the source database. Now we have to create a tuning task for the SQL tuning set, and we are going to use this command that I am pasting here. Just to explain, we are defining a variable, say vtask. This will hold the name of the task, and we are executing this DBMS SQL PA, that is SQL Performance Analyzer, and create analysis task procedure for the SQL set name SQL set catdb with the date that we created in our source database, if you remember. And finally, we are printing the name of the task that we created. So let's copy it from here and paste it in the command prompt. And it has been successfully completed, and a task with the name task 294 has been created. We have to make a note of this task name because this is going to be used in our subsequent commands. Next, we need to create a script, that is a shell script, which will be actually executing this task in the background. So let's go back to our command prompt, and we are currently under this rat rip directory, and we are going to create one script, say with the name rat test before replay. So it is the database name. Before replay is just for our understanding .sh. Let's first specify the cell and a few other settings there. We are setting the database environment in this script so that it can connect to our target database. So the Oracle base, Oracle home, the library path, SID, unique name, TNS admin, and the path variable. And we are simply using the PL SQL block here to be executed in the SQL prompt within this end of file tags. So what it is doing, it is using the DBMS SQL PA package, and it is executing the analysis task. And the task is nothing but the task underscore 294 that we just created in the previous step. And it's of execution type test execute, and execution name we are providing as before replay. And we are supplying some execution parameters here. So DBMS advisor.argument list, and we are providing only one argument here, the disable multi execution, which is true. Now save this file and change the mode to 775 so that we can execute it. Next, we will run this script in the background using the nohub command. So now this script is executing this task 294 and we are naming it as before replay. And this is going to run for a couple of minutes. And we can check the status of this task using this SQL query, that is the task name, execution name, status, execution end from the DBA advisor executions, where task name equal to task 294, and it says that it is completed. Now we can check how many objects have been created by this before replay task. So I'm using this query, select count star from DBA advisor objects, where task name equals to task 294 and execution name equals to before replay, and we can see that it has created 83 advisor objects. Now before we start our replay, there are a few more small steps involved, and the first of those, the process capture step. So we are executing one command called dbms workload replay process capture, and the capture directory is catdb replay. So whatever capture information is there available in this catdb directory, it will process that. So we will run it and it should take a few seconds. Yes, it is completed. And then we will run another command to initialize the replay using this command, dbms workload replay dot initialize replay, and here the replay name we are supplying as catdb replay, and the replay directory is also catdb replay. In fact, you can choose a different name here, but I prefer to keep the same name just for easier understanding. And I'm going to execute it, and it has been completed. Next, we need to prepare the replay, and to do that we are going to use this command, dbms workload replay dot prepare replay, and synchronization equal to false, and it has completed within a second. Usually in a real database environment, this prepare replay step takes a couple of minutes. Now we have to start some workload replay clients in the target system, and I'll show how we can create this or start these replay clients. And this is nothing but the WRC executable that is found under the bin directory of the Oracle Home, and the mode will be calibrate, and the replay directory is our directory that we created for keeping all our replay related files. Now press enter and it will give us some information, and also giving us some workload characteristics that we captured, where the max concurrency was 2 sessions and the total number of sessions were 7. It is also giving some assumptions like 1 client process per 100 concurrent sessions is suggested. In our case, as it's very less, then 1 client process is enough for our purpose. So we are going to run 1 client process for the workload to be replayed, and that has to be done in the background using the nohub command. So what I am doing here, nohub Oracle Home bin WRC, and here we have to supply the password for one of the DBA users. In our case, the system user has the password rat test1, so I am keeping it that way and running it. So this workload replay client is currently running, and we can check it using the job commands, and we can see that currently this workload replay client is running. And now actually we have to run our workload replay. So So we'll come back to our SQL prompt again. Set timing on, and we will run our replay using the DBMS workload replay.start replay procedure. So this start replay procedure has been successfully submitted and it is currently running. Now please remember that whatever amount of time we have used to capture the workload, this workload replay is going to run approximately for that amount of time. If you ran your capture for 15 minutes, then the replay will also run for 15 minutes. If you ran your capture process for an hour or 2 hours, then this replay process will also run for that long accordingly. Although in the first I have run the capture process for just 15 minutes, actually it did not capture anything for that 15 minutes because it was a very short amount of time, and so I had to run the capture process again for like 1 hour or so that it actually captures something which can be replayed in the target system. So in this case, the replay process is also going to run for 1 hour. We can actually check the status of this workload replay using this query. So select ID, capture ID, name, start time, end time, status from the DBA workload replays, and currently there is only one replay which is in progress. So we can keep checking the status of this replay process, and it will run for the next 1 hour. After 1 hour, we'll check whether it has successfully completed or not. Let's check the status of the replay again. And yes, this time we can see that the status is completed. In the next, we will extract the comparison reports and make our performance analysis. There are a few more tasks or steps that we need to execute before we can extract the AWR reports. First, let's go to the target server, and I'm currently in the Oracle users home directory, that is the home Oracle directory. Then we'll go to the rat rep directory, which is the location where we are keeping all our replay related files. And we'll make a copy of this rat test before replay.sh, this script, and we'll make a copy and execute it as a after replay task. So first, let's make a copy and make necessary changes. And all we are going to change here is the execution name, and instead of before replay, we will put here after replay. And we are keeping all the other parameters the same. The task name, that is the task 294 that we found out before. The test execute is the execution type, and we change the name, and the execution parameters. DBMS advisor argument list will be disable multi-execution true. Let's save it. Now we'll run this script in background using NoHub. Let's connect to the target database as sysdba and find out the status of the task currently getting executed using this SQL statement. Select task name, execution name, status, execution end from DB advisor executions, where task name equal to task 294. And we see that the after replay that we just executed has also completed. So once the after analysis task is complete, we must run a comparison analysis task. I'll write another shell script to run a comparison analysis task using name value pairs in the execution parameters and run it in the background using NoHub. So I'll go back to the Unix prompt again, and I'll make another copy of our source script, that is red test before replay sh, as compare replay.sh, and we'll make necessary changes in this compare replay sh. So the first part where we are setting up the environment for our target database red test 1, and the other changes I am just going to copy paste here, then I'll explain. So within this begin end pair, I'm putting the DBMS SQL PA, that is the package for performance analysis, and we are using the procedure called execute analysis task. The task name is again task 294, and this time the execution type will be compare performance, and execution parameters will be DBMS advisor argument list, the execution name 1 before replay and execution name 2 after replay. So this comparison task will compare the before replay and after replay statistics. Let's save it and we'll run it in background again. So no hub, compare replay sh, and the log will be redirected to compare replay.log. Now again, log into our SQL prompt and check the status of the job using the SQL statement. Select task name, execution name, status, execution in from DB advisor executions, where task name equal to task 294. And we can see that the latest task with an execution name equal to execution 501 completed. The name execution underscore 501 is taken because we did not explicitly define an execution name for the task. Once the compare task is completed, we are ready to generate our AWR reports. Usually, we generate 3 different types of AWR reports after the performance comparison is completed. The first one is a replay report that gives us the replay related statistics. The second one is a comparison report that is usually generated if you have multiple replays and you want to compare between any 2 different replays. And the third one is a SQL performance analysis report, and that is the most important report for us, which gives us the improved, regressed or unchanged SQL statements. In this tutorial, I will extract the third report for demonstration purpose. However, I have mentioned the code to extract the first and the second reports in the shared document in my Google Drive, and the link for that can be found in the description of this video below. Now let's go back to our SQL prompt and extract the report. Let's connect to our target database as sysdba. Set the page size to 20,000, line 200, long 10 million, long chunk size as 1 million. Then spool the output to a report in the HTML format with the name spa catdb radtest1.html. And I'll use this SQL statement to extract the report. Select DBMS SQL PA dot report analysis task, task name task 294, type HTML, section all from dual. And the moment I hit enter, it's going to run for some time because it's going to be a big report. Usually it takes like a minute or so. And it started spooling the output. And spool off. So it has completed writing the report in HTML format. Now go back to our Unix prompt and we can see that this report spa catdb radtest1.html has been created. Now we need to transfer this to our local machine. And once you open the report in a browser, it will look something like this. The top few sections will give us some information about the replay, the execution, the task, and analysis information, before change execution, after change execution, etc. And the most important part is this summary section, where we get the information about the impact of our change. For example, in our test case, we upgraded our database from 18C to 19C. So what is the impact of the SQL statements in this upgrade activity? So we can see that the overall impact is 27% and it is green. The improvement impact is 31% and regression impact is -4. It means there are some SQL statements which have improved in performance and some SQL statements which have regressed in performance. And we can get more details about those SQL statements. For example, the overall SQL count is 82 and plan change count is 0, means there is no change in execution plan of the SQL statements. And there are total 5 SQL statements which has improved in performance, and there are 3 SQL statements which actually regressed or the performance has degraded. And there are 44 SQL statements for which the performance has no change. And there are 27 SQL statements or PL/SQL blocks which are with errors, and there are 3 unsupported. These 2 last lines we can ignore for now, and we can focus on the other areas. So these are the SQL statements which have actually improved in performance, so we don't have to worry about that. And these last 3 lines in red are about the regressed SQL statements. So if we click any one of those, it's actually a hyperlink. It will take you to the detail section about that SQL statement. So here, this SQL statement was with this text, and we have all the information about what was the before value and after value of certain parameters. For example, the elapsed time, parse time, CPU time, user IO time, etc., etc. And you can also compare the execution plan if there is any change. As we have found in the summary section already that there is no change in any of the SQL statements execution plans, so we will not be able to see any change in execution plans here. Let's go back to the top sections. Let's take the second SQL statement which actually regressed. Say this is the SQL statement from our test application user called app user, and this was the SQL statement which has actually regressed. And if you see, there are very minor differences in the before value and after value for certain parameters. And for example, if you see the elapsed time, it has a little bit increased here. The parse time is good. The CPU time is actually more, and user IO time is actually less. Buffer gets actually increased. Cost is unchanged. Reads decreased. Writes no change. And IO interconnect bytes, it is actually reduced. But the overall impact is this SQL statement has regressed in performance. And now it's up to you how seriously you take about fixing that regressed SQL statement. If it's a regular SQL statement that runs a few thousand times or few hundred times every day, then probably you should pay more attention in fixing it. But if it's an ad hoc SQL statement, probably you don't have to pay much attention and you can simply ignore the regression here. For the important SQL statements that comes from the application and the performance is really critical, you have to analyze the before and after value for certain parameters, and you have to find out what might have caused that. For example, you may have to increase the memory footprint or certain server resources like CPU or memory, or you may have to adjust certain init parameters of the database. And once you are done resolving the issue, run the replay again and extract the reports. This time you can also extract the compare period reports between the first and the second replay. And if you want to repeat the whole replay again, then simply flashback the database to the granted restore point that we created before and perform the steps maintaining the sequence. So that's all on this topic, and I hope you'll be able to use this nice feature in Oracle in your future database environment changes like upgrades or migrates or hardware upgrades, etc., for a comparison of the before and after performance of the database and complete your change successfully. So viewers, I hope you enjoyed the video and found it useful. Please hit the like button if you liked it and subscribe to my channel so you won't miss an episode in this series for the Oracle DBAs or similar educational videos that I am uploading every week.